Good morning, everybody. Welcome to reInvent. I think this could be is this your first session of reInvent? It is 10 o'clock in the morning. Well done. I really appreciate that you're actually spending it with me, so thank you so much. Welcome to Scaling Serverless Data Processing with Amazon Kinesis and Apache Kafka. We are going to be speaking about a whole bunch of things today, and we're going to be talking about how Kafka and Kinesis connect with Lambda. Now, I appreciate there are probably two types of people in the audience. Maybe you are a Kinesis person, or you're a Kafka person, or you understand streaming, and you're thinking, this is interestingly, how can we use Lambda to process our data streams? And then there may be other people in the audience over here who use Lambda a lot and think, we use Lambda for APIs and event-driven architectures. Wow, I wonder if we could extend that use case to Kinesis and Kafka as well. So that is a bit of a thing that if you're sitting in the audience and you go, yes, Julian, I know this, let's get on to something else, maybe have a thought for the other half of the room who are coming at it from a different perspective. But I hope I can be able to at least bring both of you together to be able to do effective data processing. There is this resources page. I'll share it again at the end. It has the slides for all the presentation, so you don't have to go too nuts taking too many photos of the video. And also on this resources page, there's some great learning guides diving deeper into some of the additional information. So yeah, plenty of stuff over there to do with from Lambda and the Kinesis and Kafka side, and generally on data streaming. If you're wondering who I am, well, I'm Julian Wood. I do have slightly longer hair. That's what lockdown does to you. But I'm a principal developer advocate here within the AWS serverless team, and I work in a super cool team as part of the product organization for serverless in AWS. And I help developers and builders best understand how to build serverless applications, and also importantly, act as your voices internally to make sure that we're building the best serverless products and features. So talking about the first thing, let's just understand a little bit about what data streaming is. Because the world is moving from a lot of silo data, where things were in Hadoop silos or other kind of databases in different places, to more sort of modern data architectures, where we want to integrate your data with other systems. Having it in one place isn't going to be helpful for your data. And so we want to connect things, and this can be with databases with Aurora, NoSQL databases like Dynamo. Maybe you're going to do some machine learning inference with SageMaker, and of course with Kafka and Kinesis to do some of the streaming movement of that data, or doing something with search with OpenSearch. You know, S3 is just massively scalable and amazing to store a whole bunch of data. The whole point is you don't want your data to be sitting in an isolated silo. You want to be able to connect it all together. And we want to get from the sort of historical to real-time analytics. So from traditional batch operations, which would run sometimes only at the end of the month, or sometimes to every single day if you're lucky. Well, you wanted to be able to have this traditional batch intelligence also move to more reactive stuff, where you can do some reactive things, maybe actionable things, and to have even preventable things and predictive things. And the whole idea is to be able to do things quicker with your data rather than having to wait for a long time. And the point is to get timely insights to new information. So comparing processing and stream processing, you want to move from the batch architectures, which creates a whole bunch of new capabilities. Examples over here from hourly server logs to real-time metrics, from weekly or monthly bills created by a job, to maybe a system that can do more things on real-time spending alerts, and then maybe implementing spending caps if that's something that could be useful to you. Or click streams from websites, instead of getting a daily report at the end of the day, well, you can do real-time analysis to work out what your customers are doing. And customers like financial institutions who obviously, fraud detection is really important. Well, critically, they want to have this information to be able to drive intelligence as fast as possible with real-time detection. And talking about common use cases, let's pick a few. Say industrial automation. Sensors are going to collect data from a large amount of devices. Online gaming is very popular, where you maybe need to keep player statuses up to date during a game. And IoT is also popular. Streaming data from devices. These could be consumer appliances or embedded sensors, or maybe TV set-top boxes. And also putting things in a data lake, so you can filter and aggregate and put things in S3 to create these huge data lakes which enable analytics and machine learning. And then log data, really popular things for streaming. You're going to get events and sources from things like servers and desktops and maybe mobile devices. And then you can build applications to actually process the data. You can use it to maybe generate some metrics, maybe power some live dashboards, and then maybe you're going to emit also some of this information into S3. So it's all about unlocking the potential of data. We talked about the real-time things. We talked about customer experience that you could do far more quicker and make it a much better. You can build event-driven architectures where you have microservices that are segregated, allows each microservice to evolve independently, but be able to stream data between them. And decoupling microservices is a really important way when we're building bigger and bigger applications. And change data capture is a really cool way to use streaming data as well. You're writing things into a database and can automatically kick off some other process based on that. An update record, a new customer field just appears in a database, and you can kick something off that really effectively. And if you want to think of the way data works with streaming, it's in effect a pipeline. And you've got initially this data source, and these are these applications that produce the real-time data, often with really high velocity. And then the ingestion part. This is the data from all these thousands of event sources need to be collected and ingested in real time. And you've got the storage part of it. Data storage, data needs to be stored in the order that it's received for a set time, and then can be replayed by a bunch of consumers indefinitely during that time. And of course, with streaming data, there's a lot of analytics integrations. Records can be read and processed in the order they have been produced, and this gives you the analytics or some streaming ETL. And of course, ultimately, there's often a destination where you may be sending data to a data lake, or something like an open search database, or something like an event-driven application. And so if we think about some of the characteristics of streaming data, well, high volume, organizations collecting clickstream data, this can be huge, a huge amount of data. Log data can be huge as well. IoT data can be enormous. It's nearly continuous rather than discrete, and this is the distinction between a batch, where you're processing a huge big chunk of information. Streaming data is normally continuous. IoT devices connecting data continuously and then at regular intervals. That's one of the characteristics. Ordering is a very important characteristic of streaming data compared to some other ways of doing data. I mean, the example here, for example, a chat application isn't going to make much sense if the messages are going to be out of order. And log messages as well. If log messages are out of order, that's going to be super confusing. Time sensitive as well. The point of streaming data is you want to do analytics and do things really quickly. An example here showing fraud detection. Obviously, a bank would want to do that really quickly. And one of the cool things all about streaming data, just an additional characteristic, is often you have multiple consumers for different use cases. In some other event architectures or queue architectures, you maybe only have a single consumer, but in streaming, you've obviously got many consumers, and that's comparing it to a queue. So let's now talk a little bit about streaming on AWS and how you can do data streaming on AWS. Well, the services we're going to be talking about today, because you're in the right room, is all about Kinesis data streams and then all about Apache Kafka. Now, Kinesis Data Streams enables your organization to set up streaming and addresses some of the challenges of streaming by being easy to use. That's really one of the things of Kinesis, and it's got to be elastic, and it's got to be durable, and also cost-effective. And we're going to focus on Kinesis Data Streams today because Kinesis is actually a whole family and suite of different products, and Kinesis Data Streams is going to be the single place to collect and store the streaming data. And then other services like Kinesis Data Firehose often gets data from Kinesis Data Streams and then can send it on somewhere else for further workflows or analysis. On the stages of processing data, then Kinesis Data Streams is going to do the stream ingestion and stream storage. Now, from here, when I just talk about Kinesis, I'm going to be talking about Kinesis Data Streams rather than the other bits of Kinesis. So, hopefully you're not going to get too confused with all the other different Kinesis products and services that are over there. And as I mentioned before, Kinesis, the point of Kinesis is to be easy to use. Literally, I think it's sort of under 10 minutes in the AWS Management Console, you can set up a Kinesis stream. And a stream defaults to an on-demand mode, and this is super helpful because it's going to automatically scale in response to incoming data loads. And it's designed for cloud-native applications and developers who don't want to handle managing servers. We are talking about more serverless kind of things. Kinesis fits into that grouping. And it's, of course, got easy integrations with other AWS services and toolkits and also many third-party applications. And also, since Kinesis is really the backbone of streaming data, and internally it's used a huge amount at AWS as well, we need to guarantee secure and durable storage so that your data is safe and so you can replay it when you need to. So this diagram shows an example of maybe how some people are going to use Kinesis in their solution landscape. And we've got multiple options, like AWS IoT Core, which is going to be a producer to ingest data from lots of streaming sources. And then once the data is in data streams, customers then have many options to extract or transform it for analysis. This example uses Kinesis data analytics to generate some real-time insights. And of course, you can use Lambda functions, which we're going to cover a lot today, for any kind of data transformation to process your data and send it on. And then, you can use Kinesis with other services like S3 or to send data outside AWS. So the default retention period for a stream is 24 hours, but many customers need to store data for longer. So we see organizations configuring this basically according to their data replay and retrieval needs, and this can be for up to a whole year. And to further help you with managing your sort of growing data volumes, Kinesis, I mentioned before, this on-demand mode that provides just hands-free scaling for your data streams. So instead of having to manually adjust, the number of shards in a data stream, you can just let Kinesis figure it out by itself. And when it detects a potential throughput issue, it's just going to sort it out. And this is now actually the default option when you create a new data stream, and you can easily convert from the existing provisioned data streams, and that's another mode that you can use Kinesis in as well. So just looking on the sort of Apache Kafka side. Now, I sometimes think that actually Kafka's got a sort of a bit of an identity crisis, because is it in an enterprise service bus? That's what a lot of customers have used it for from many, many years for that, as a place to store all their events. But then some people think of it a place to put data via a REST call, but then process data afterwards asynchronously. And also, some people use it in a bit of a database way where you can query data from a particular site, from a particular time. And in a way, Kinesis is actually all of these things, and Kinesis likes to brand itself as a streaming platform because it has got a really lot of wide use cases and sort of stretches into some of those event service bus and queuing use cases you may use because it's very common specifically when you're using it on premises or in your own data centers, that you haven't got the luxury of having a lot of different other products and services, and so you can actually use Kafka to do a lot of things. And in terms of running Kafka, well, of course, you can run it yourself, and this can be on-premises in your own data center, also in the cloud, just installing it on an EC2 instance, for example. And then we do have Amazon managed streaming for Apache Kafka, Amazon MSK, where we're just going to handle a whole bunch of that stuff for you as well. A lot of customers using, one of the original developers of Kafka being Confluent, and Confluent has this two great ways to run it themselves, a SaaS-based model with Confluent Cloud, or also you can use the Confluent platform. So this allows you to install Confluent platform yourself, again, in your own data center or on EC2 in the cloud. So just talking about Amazon MSK, and this makes sort of Kafka really secure and highly available and accessible within your organization. And the sort of point of MSK is to focus, so your developers can focus more time on building applications and less on all that sort of infrastructure management, because it's got this automated provisioning, configuration, and lots of performance tuning built in. And that's not just the Apache Kafka, it's also the Kafka Connect clusters as part of that. It just manages for you. Of course, it's fully compatible with open source Apache Kafka. So if you've already got applications and tools that are built for Apache Kafka out of the box, there's no application code changes required, and that's obviously super helpful. It's, of course, very highly secure. Security, we always talk about that at AWS is job zero. Well, this allows you to deploy production-ready applications. It's got native integrations to VPCs if you need it for authentication and authorization. And of course, there's a cost element to this as well. Fully managed Apache Kafka with all of the other kind of things in terms of managing it. Some people have told us that it's up to 1/13 of the cost of other providers. And there's a sort of graduated scale you can use, which you can show how Amazon MSK can work. On premises, you literally need to do everything from the power and the network all the way up to the scaling and your application development. If you do things on EC2, well, of course, we're going to handle the hardware for you and the operating system install, but then the rest of the stack you're going to have to look after by yourself. And so, driving home the point of MSK is just being able to offload a lot of that undifferentiated heavy lifting, which is a term we like to use at AWS. So you don't have to handle that, and you can spend your time looking after your streaming applications. MSK itself has a serverless model as well, and this provides a serverless runtime for Kafka. And so this means you don't have to configure or optimize or secure or operate clusters to run any applications. And you really don't have to now worry about under-provisioning resources for your data processing jobs. In terms of payment, you pay for how much data you stream and then how long you're actually going to store the streaming data for. So, this is another level of Amazon MSK, and really, if you don't want to have anything to do with operating clusters and just simply want to run your applications, then I suggest giving MSK serverless an option. So, now time to just have a look more in streaming architectures, and what is a stream and what is it made up of? Well, on the Kafka side, we're going to talk about clusters, brokers, topics, partitions, and records. And just to say, in this presentation today, I'm going to talk about some Kafka things and some Kinesis things, and sometimes I'm going to talk about them together. So hopefully we're not going to get too confused between the two different things, but hopefully it should be understandable. So with Kafka and Kinesis, you obviously got the concept of producers and you got consumers. Producers are going to produce records that go onto a stream, IoT data or clickstream data or financial data, and then you've got consumers, multiple consumers often, that are going to consume that data and do something with it for your application. Then for Kafka, in the Kafka world, in the middle, we've got brokers, and these are basically EC2 or your own servers in your data center running Kafka. And even with MSK serverless, there are still brokers there for you, but it's all managed on your behalf. And then topics are a message channel to then store similar records. And you may have a single topic for everything, or maybe for different applications, or maybe different departments. Here we've got a single topic, topic A. And then partitions then partition the data to manage the processing and throughput, and then the partitions are replicated across all the brokers for availability. So that's how you get high availability. On the Kinesis side, of course, there are producers and consumers, as I mentioned before, but as Kinesis is generally a bit more serverless already, there's no brokers that you need to think about, just a single stream, which you can think of like a topic. And then you can create multiple streams to segregate messaging between applications or different teams or business units. And then within the streams, they are then split into shards. And the shards are like partitions in Kafka to handle processing and the throughput. So we've got partitions in Kafka and we've got Kinesis shards. Producers are going to put messages onto a particular shard or a partition. And these are then an ordered set of records. And the important thing to know is that new records are always added to what's called the front of the partition in the shard, and then older messages just age out by storage or by time. So depending on the configuration and what service you're going to use, there's a stream could have a fixed amount of time or a fixed amount of storage, and old records just sort of disappear out of the end, and new records always add onto the front. The new data writes are onto the front. And obviously, these partition keys, the partitions you can manage with partition keys. And a producer can specify a particular partition key, and this can be varied. It can be sort of any kind of thing you can use. And basically, there's then an MD5 hash function, and then the broker or the Kinesis is then going to use that hash to then place the record on an individual partition or an individual shard, and that's always going to be in order. And then you can use multiple partition keys, and they can land up in a single shard. So in this example over here, you can see the partition key 2 and partition key 3 are going to be hashed, and they're always going to land up in this partition 1 or shard 2. And the cool thing about this is it's always deterministic. With the MD5 hash, it's always going to land up in the same partition, and that's how Kinesis or Kafka is going to maintain ordering for your applications. Now, partition assignment can be really useful because this is what you can use in your application. So you can use a random hash for your partition key, and this allows records to be randomly sent to a whole bunch of different partitions, and this effectively load balances records across all available partitions and is often going to give you as much the maximum throughput that you can have. You could choose to do a time-based hash, so a group of records to a single partition if the records arrive, sort of at a similar time. And then an identical timestamp, maybe on a minute or an hour, then results in an identical hash. Or you can use application-specific ones. So, for example, customer ID, you could use that as the key. All records for that customer are then going to be routed to the same partition, then always arrive in order. And this is useful for downstream aggregation logic. But you also do need to be aware that if you have one busy customer, that could use a lot of information in a single partition compared to the other customers. So for Kinesis, we have an offset, and for Kafka, we have an offset. Can't believe I'm confusing you already. I'm the one meant to be telling you the right kind of things. We're getting them mixed up. Kafka has an offset, and Kinesis has a sequence number. And this is basically the same thing, and it's to track where the consumer is reading from in the stream. So here we've got consumer 1, which has an offset of 4, and we've got consumer 2, which has an offset of 7. And it's just a way that multiple consumers can be tracked within the streaming application to know where they are in the stream. So we've talked about a whole bunch of the technology, and I landed up confusing you myself anyway. So just to reiterate that a stream and a topic for Kinesis and Kafka are pretty much a similar thing. A shard and a partition, you can think of the same thing. An offset and a sequence number, similar kind of things. obviously, Kafka needs to talk about individual servers, so they have clusters and brokers. And the one other thing is just, data, records, events, and messages are used interchangeably. There are lots of resources and, things you're going to be talking about, and you can just think of those things as the same kind of thing. There isn't necessarily a difference between the different services. So now, how can you actually process some of that streaming data? We've talked a lot about what a stream looks like. What are the options? So for consuming data on the Kinesis side and the Kafka side, there's some similar services we can use. We've got Amazon Event Bridge Pipes. That's one way you can consume data records. And then we've got the Lambda event source mapping. And then on the Kafka side, you've also got Kafka Connect. So if you are in the Kafka kind of world, very common way to use Kafka Connect to connect to other different services. So Event Bridge Pipes, what is that all about? Well, Event Bridge Pipes is part of the Event Bridge family, and this lets you focus on what differentiates your business instead of writing undifferentiated glue code. And it's a simple way just to create point-to-point integrations between producers and consumers. And you actually set this up as configuration code without having to write Lambda function code to actually transport the data. And Pipes has got, I think, 6 sources, the ones you see here, including self-managed Kafka. And then they've got enrichment through 4 different services, and then delivery to 14 other services, including HTTP endpoints via API destinations. So this allows you to maybe connect your data streaming to even any API on the internet, or even a bunch of whole third-party SaaS providers. And then central to Pipes is the ability to filter, so you can choose events what you want to keep. And then there's also this enrichment and transformation step, which is also optional, which allows you to go to all these different kind of services to add more information to the data records on your stream, and then send it on to a target. So this enrichment could be maybe grabbing something from something like Zendesk, for example, that can get ticket information from your ticketing system, and then add that into the event before sending it further on. Some use cases which people use Event Bridge Pipes for is, for example, within Kinesis, you want to split one data stream into separate domain streams, so that maybe they're going to be used for different applications, and you simply do a filter configuration in Event Bridge Pipes and then split it to 2 separate Kinesis data streams. Again, you're not writing any Lambda code to do this, it's just going to do it for you as part of the filter configuration. On the Kafka side, you can use connect to an API destination, for example, or you can use SageMaker for some machine learning inference. And again, this example for the enrichment step, you could use Zendesk, for example, add information for your ticket info before passing the record on. So a really sort of simple way to be able to do the connectivity. On the Kafka side, there are basically 2 ways other than Event Bridge Pipes to talk to for Kafka consuming with Lambda, and one of them is using the sync connector, and this also includes then the Confluent sync connector. And the Confluent sync connector is going to take polling the partitions and then calling your Lambda function to deliver the messages. Or you can actually use the native integration with Lambda, which we're going to cover a lot, called the Lambda event source mapping. And either way, you're basically not running your own polling code. The services are going to manage that for you, and that's going to be super useful. So just talking quickly about Kafka, Confluent, Lambda. It can call Lambda in 2 different ways, in synchronous modes, records within a topic are then processed sequentially, and Lambda success response is then going to be written to another successful Kafka topic. In asynchronous mode, the connector basically works in fire and forget mode. Records are processed on a best effort and also in a sequential basis. Now, because Lambda can be called asynchronously, it does have at least 1 semantics, so your functions need to do the work idempotently, which means that if you could write the same record to a database, it's not going to cause you any issues. Idempotency for any stream processing or any distributed system is something you should be looking at and is super important. It can also optionally batch the records and send it to your function. This is useful to control your Lambda costs and then produce a batch of records together. The Confluent Sync connector does scale to a max, I think it was, of 10 connectors, and then you can request more from Confluent if you want to. And in terms of the error handling, it's going to send the errors to different kind of topics. And since Lambda can be called synchronously or asynchronously, the error handling is similar to how Lambda works. On the async mode, records are actually pushed to an internal queue, and Lambda is going to retry twice automatically for a total number of 3 retries. And then also you can choose to push failed records to what's called an on-failure destination. So this is something you configure in your Lambda function configuration to say if something fails, send it to, and I think it's SNS and SQS, Event Bridge, and another Lambda function. That's another option you've got. So lots of options available for your error handling. So next I want to cover the Lambda event source mapping and how that works for both Kinesis and for Kafka. So the Lambda event source mapping is a polar resource that reads items from a source. And it can be Kafka and Kinesis, but it can also be DynamoDB streams, it can also be SQS, it can all be Amazon MQ. And basically, the polars pull messages from these sources, can optionally filter them, batch them, and then send them to your Lambda function for processing. And the really cool thing about the ESM is actually we run these polars on your behalf. So you don't have to manage any polling code to do this for you. And you don't need to write code, in the Kafka world to maintain the offset per partition, which is a bit of a hassle, which you need to do. Basically, Lambda takes care of managing that offset for you and managing the polars. All you need to do is write your business logic. And the cool thing about these polars is it's completely free. It's just part of the Lambda service. You don't actually have to run your own EC2 instances or your own containers to do any of the polling. The Lambda event source mapping is going to do it for you. And the benefit of using Lambda is that, Lambda's just going to handle the scaling. Lambda's got amazing scaling to be able to scale up and allows you to focus on your custom business logic instead of all the underlying infrastructure. Lambda supports a number of language runtimes, from Python, .NET, Node, but you can use a custom runtime to run literally any language on Lambda. We've got people using COBOL and PowerShell and PHP and Erlang, and literally Lambda is pretty much agnostic to your choice of language. And this is actually quite a useful thing because it's much easier to have multiple consumers, and multiple teams can actually write their own Kafka consumers in different languages, and that may be super useful for you, particularly in the Kafka world where everything is a lot in Java. You maybe want to have some teams who are more proficient in Python. They can really easily write Python applications without having to worry about all the polling that's going to be happening in the background with Java. So then records are delivered as a payload to the Lambda function, and then you can configure how many records there are in each batch, and this is literally up to 10,000, so it can be a huge batch. So once the record is then finished processing, it's going to return the result to Kinesis and Kafka, and that's how it's going to do the processing. Now, you may be thinking, event bridge pipes, this all looks a little bit similar. Well, actually, event bridge pipes uses the same Lambda event source mapping under the hood. It's literally exactly the same technology. So you can use pipes for some sort of simple data transformation, and then anything that needs a little bit more complex workflows, or pipes has got 14 destinations, Lambda can send something to anywhere, then you can use Lambda for those use cases. And the ESM supports a number of event source features, the filtering we spoke about, configuring batch sizes and windows, and reporting on partial batch failures for Kinesis, and a whole raft of settings depending on the event source. And you configure these on the event source mapping, which makes it really easy to process data at scale with Lambda. So let's have a look at sort of the workflow of how the ESM works with both Kinesis and Kafka. So the event source mapping then includes this polar, which we spoke about, and this is going to poll the stream every second and then checks whether there are any new messages available. Now, in terms of where to start, well, you can actually configure the starting position as part of the event source mapping configuration. You can start at the trim horizon, which just starts at the earliest record that happens to be in the stream before anything has been aged out. You can record from a specific timestamp. So yeah, you just select your at timestamp and your reading will go from there. Or you can do from the latest. And this starts reading from the latest record once Lambda has configured the ESM. So it's going to take a little bit of time. It's got to set up the polar to get the ESM up and running. So there may be a possible delay once you've clicked the enable polar, enable event source mapping before Lambda is processing the first record. Then from the Kafka, this is not applicable to Kinesis, but on the Kafka side, you have got a consumer group ID, which you can actually now customize. And this is what the consumer ID is what uniquely identifies a consumer in the Kafka world. And this feature works both for MSK and the self-managed Kafka event sources. And if you don't specify one, well, the Lambda event source mapping is just going to create a unique UUID one, and that's going to act as a new consumer. It's also interesting to know that if you delete a Lambda ESM, it does not actually delete the consumer group, so you could reattach to it a little bit later. And the cool thing is now you can actually create custom consumer group IDs. So when Lambda identifies when Kafka identifies a Lambda function being attached to a Kinesis stream using an existing consumer group, then the consuming instead starts from where Kafka recorded the consumer group had last processed, or from the trim horizon if that is no longer applicable. This can actually be really useful in disaster recovery scenarios. So if you're using something like Apache Maker 2 with Lambda, Apache Maker 2, this is going to make a duplicate copy of your stream. You can then use Lambda with that custom consumer group ID to then resume processing from that mirrored Kafka cluster and continue processing where you left off in your disaster recovery scenario. So once the polar has the records, it can then optionally filter them. And this is super helpful because it allows you to choose which records you want to process. And that filtering is obviously going to happen before invoking the function. And the cool thing is also it's going to reduce the costs because you only need to process the records you care about. The records aren't going to go to your Lambda function, and then you're going to land up having to dump them over there. So the filtering is configured using a JSON pattern. Here's an example here with a lot of different pattern matching options. And in this example, it's going to check a numerical value and only process if the tire pressure value is less than 32. So that may be a use case for you, but lots of different use cases. I think it's got suffix matching and greater than and less than, and there's a whole bunch of things. And actually, the event bridge pipes filters uses the event source mapping under the hood and uses the same syntax, which is really great for consistency. So if you are building applications with these various kind of services and you're building up your filter patterns, they're all going to be consistent. And of course, that you can have then multiple event source mapping resources with different filters, and this allows you to pick up only messages relevant for them. And I showed that previously with that Kinesis example, where you have one Kinesis stream and you've got, well, I used that with event bridge pipes, but you could use it with Lambda as well, where you could just have two consumers with two different filters and sending data off to separate places. So then after filtering, the event source mapping is then going to group the messages into batches before sending it onto your function. So how are batches defined? Well, there's actually a combination of three ways. You can configure the batch size, so how big it's going to be. By default, it's going to be a batch size of 1, but that can be up to 10,000. You can also configure a batch window, and this is configurable from immediately to up to 5 minutes as a set period of time. And then also, you need to take consideration of the Lambda payload size. The Lambda payload size is a maximum of 6 meg, so you can't send more than 6 meg to a Lambda function. So let's see how this works in practice with all three of the batching options. The max batch window in this example is set for 40 seconds, and the batch size is configured for 10. And remember, the Lambda maximum payload is 6 meg, which you can't change. So in the first scenario, the max batch window starts from around 7 seconds. And so at 47 seconds, that 40 seconds of time has elapsed. And so the max batch window has been reached. And so this is then going to send 5 records onto your Lambda function. In a second scenario, before the actual window ends, so in under 40 seconds, there are already 10 available records to send onto your Lambda function. You've configured 10 as your batch size, and so that's going to be sending 10 records onto your Lambda function. And then the third scenario, before the window has been reached before the batch size has been released, the payload limit size for Lambda has been reached for the size of maximum 6 meg, and so 6 records are then sent to your Lambda function. So hopefully that explains how the sort of 3 different batching options work all together. So once the event source mapping has decided on the batch size and send it to, it's then going to send the records to your Lambda function synchronously, and then the response is going to be then sent back to Kafka or Kinesis. And I'm going to cover what this sort of success and failure looks like shortly. So here are just 2 examples of what a batch looks like for both, and this is what the Lambda function can then parse and analyze and process your records. And the event is going to include the partition and the shard information. It's going to have a timestamp. It's going to have a sequence number, and then an array of records that your function can process the individual records within that batch. Now, just something that Kinesis does, which is really cool, is there's a helpful additional setting called tumbling windows. And this you can use for some simple data aggregation. So what you can actually do is you can pass the state across multiple Lambda functions to calculate aggregates in sort of near real time. And this is maybe an alternative way which you can use for some analytics solutions when it's going to be simple enough. So a tumbling window in Lambda is a fixed size time interval which you configure within your event source mapping of up to 15 minutes. And then records in the stream are then grouped by the window and then sent to the processing Lambda function. So in the example here, this function returns a state that is then going to be passed to the next tumbling window. And here, the stream has got 4 windows over 60 minutes. So the first window contains items 1 and 5, and then the function is going to sum these up and return the value 6. And then the sum result is going to be passed to the next tumbling window, which is then going to add 3, 2, and 7. And that brings the total to 18, which is then passed to the third window, and so on, and this can keep going on. So in terms of what arrives in the Lambda function, this is what it looks like. The incoming event is all the same as before. Kinesis is going to provide an array of records, but what is different is they're just a handful of new attributes. The start and end time is added onto the window, and then there's a state attribute, and initially this is going to be empty. And then the first invocation returns a value in the state, in this example, an item count and a sales total. And then when Kinesis invokes the second Lambda function, it's going to pass the state it received from the first window. And then when the final invocation occurs, there's a new attribute in the event payload indicating that it's the last one, and then you can choose what to do with that. You can durably persist it to a database, or maybe send something to S3 in this example. So yeah, just an easy way that you can quickly pass data between multiple invokes of your Lambda function. Okay, so I want to spend just a little bit of time now for the people more interested in a little bit of Kafka and Lambda. But don't worry, Kinesis people, we've got you covered a little bit later. Let's just go into some of the configuration options for Kafka. So the first thing is authentication options. If you're in the Kafka world, you'll know about SASL Scram, and that's really common for Kafka, and you can actually store your secrets in Secrets Manager, and the Apollo is going to be able to use that to connect to your Kafka cluster. If you are using MSK, there's the secret name needs to be in a specific format, where there's Amazon MSK underscore to be able to do this. So the ESM is going to grab the secret and then do the authentication. Now, Amazon MSK Serverless actually only supports IAM, and yeah, this is interesting. It does make it a lot easier. You don't need to use Secrets Manager to do your processing, just a simpler thing. And actually, recently, the MSK team has released some open source libraries for Python, Node, and Go, so you can more easily add IAM authentication into your applications. Now, this is probably more relevant to when you're writing producers in other languages, or if you're running your own consumer, because remember, with the event source mapping, Lambda is handling the polling for you and handling that authentication. You don't need to do it. But if you are writing your own consumer elsewhere and using IAM authentication, it's useful to know that it's much easier now in Python, Node, and Go. I was doing some data streaming stuff earlier this year, and trying to get Python working with IAM was just an absolute pain. So it's really nice that they've released this open source library to be able to do it for you. So I'm going to take a breath here, because this is Kafka and networking. And a lot of people are like, oh, networking and Kafka, this is something that everyone has to deal with. Obviously, Kinesis is just sort of on AWS, so it's maybe possibly a little bit easier to deal with. And obviously, people working in the Kafka world are spending a bunch of time on the networking. So this, just looking initially at the self-hosted Kafka networking, is similar. Actually, it works to a Lambda function. By default, event source mapping has then access to the WAN, but then isn't configured for access within a VPC. And then you can actually configure specific subnets and security groups to then access a Kafka cluster. So the ESM can actually access the clusters that's reachable from a VPC in the same, or actually a different account that contains a Lambda function. And this is brand new. I think it's only a week ago, where you can do cross-account connectivity for your Lambda functions to a Kafka cluster in another account. Super useful, because a lot of customers are using, maybe a shared account where they share Kafka environments, and this just makes it much easier. So for the Lambda function to then poll the Kafka instances, you must ensure that there is a NAT gateway running in the public subnet of each region. Now, it is obviously possible to route the traffic to a single NAT gateway in one AZ if you are doing some test and development workloads, but for redundancy in a production workload, let's all do the right thing. And it's, of course, recommended that there's one NAT gateway available in each availability zone for that high availability. When using MSK to communicate with the MSK cluster, the MSK ESM creates an elastic network interface in each subnet that's used by the cluster. And this is actually similar to how a Lambda function works when you connect it to a VPC. Now, interestingly, an MSK ESM doesn't actually use the Lambda function's VPC settings. Instead, the ESM automatically uses the subnet and security group settings that are configured on the target ESM cluster. And the MSK's clusters security group settings do need to include some specific rules, and one of them is that it's to grant inbound access from itself and outbound traffic to itself. And then, of course, you need to grant access depending on what authentication mechanism that you've configured for your broker. Now, also, if you're using Amazon MSK, your Amazon MSK VPC also requires some additional outbound network connectivity. And this is because the traffic flow is going to go from the Lambda VPC to your MSK VPC to then invoke the Lambda function. So this needs to connect to Lambda, and it needs to also connect to STS, Secure Token Service, to assume a role for the target Lambda function to be able to connect to your MSK cluster and invoke your function. Now, also, if you're using some authentication options that are using Secrets Manager, you do need to also have access to that too. So there are two ways you can configure outbound connectivity to AWS services. You can use VPC endpoints or a NAT gateway. For VPC endpoints, you then create them for Lambda, STS, and then secrets manager if you need to from your private subnets, and this allows the connectivity to go through. If you're using NAT gateway, then you must assure that there is a NAT gateway running the public subnet of each region. And again, remember, for dev test, you can use a single NAT gateway. For prod, you need to have one in each availability zone. And interestingly, when you actually do configure the event source mapping, if there is an issue being able to connect to Lambda, STS, and Secrets Manager, it's going to tell you in that configuration, I've got a network issue, I can't connect to that, and this you'll know how, and you go and then create a NAT gateway or the VPC endpoint. So now how Lambda scales when consuming from Kafka. So when you initially create the Amazon MSK event source, Lambda allocates one consumer polar to process all of the partitions in the topic. Now, previously, this could actually invoke only a single Lambda function, but about 2 weeks ago, we increased the initial scaling so that the polar can now invoke multiple Lambda functions for even faster scaling once you start up. Lambda is then going to automatically scale up and down the number of consumers based on the workload. And Lambda is going to then evaluate the consumer offset lag of all the partitions in the topic every single minute. And then if the lag is too high, this means Lambda basically can't keep up with processing from the records from the partition. And then Lambda is going to automatically add additional polars for the topic, which then scales out to more Lambda functions. And this process can take about 3 minutes, but with the recent announcements, that scaling process is going to be really quick, and it's going to be able to scale up to the maximum number of partitions that you need within 3 minutes. So Lambda can then scale up further to the number, to scale up the consumer polars to less than or equal to the number of partitions, so it lands up with a sort of mapping of 1-to-1. And this also preserves message ordering in each partition, so of course the maximum number of consumers is 1 consumer per partition in the topic. So Lambda can scale up to match the number of partitions, and they work together for this throughput. So looking at the processing, the Lambda service polls the shard every second for a set of records and then synchronously invokes the Lambda function with a batch of records. So if the processing is successful, job done, it's just going to carry on and process the next batch. But if not, the retry and error behavior depends on the event source configuration. Now, using the default settings, Lambda is going to invoke the function again with the same batch of records, and it's going to continue to do this until the batch is successful or the records are going to expire out of the stream. But if there is an error in the batch and you don't want to retry processing the batch, you can also now configure a failure destination, again, newly announced, and instead send the batch there for further investigation. So for records that have aged out of the stream, they're going to be discarded. But for the error ones, this just at least gives you something that you don't have to hold up your stream if you've got a poison pill message and you can keep processing. So promised I'd get back to the Kinesis people. Let's now talk a bit more about Lambda and Kinesis-specific things. So as we know, a Kinesis is a stream. A Kinesis stream is a set of shards which contain the data records. And Kinesis consumers have a shared fan-out mode where up to 5 consumers, different consumers, can then share the read throughput from a particular shard. Now, to maximize throughput, you want to limit the number of different Lambda functions reading from the same stream to then 5 of those shared possible consumers. So each shard can support up to 5 transactions per second for reads, up to a maximum total data reads of 2 megabytes per second with a latency of about 200 milliseconds. And remember, the Lambda service is going to poll each shard once per second. Then for faster response times for a certain stream data, you can actually set up enhanced fan-outs, called EFO. So EFO consumers are really cool because they actually have a dedicated 2 megabyte read throughput, and Kinesis actually uses an HTTP push mechanism to get the data to the ESM faster, and this means that the latency is reduced to about 70 milliseconds. Also, ESM consumers then don't contend with standard consumers, so it's a good way to ensure consistent low latency and avoid sometimes that noisy neighbor problem you may have. And you can have up to 20 EFO consumers to a stream. So if you need high throughput, this is certainly something to look at. So let's look at the initial scaling. Well, by default, there's already a function instance per shard. This is just how Kinesis and Lambda works. But Lambda can increase processing without Kinesis adding more shards. And there's a configuration setting called parallelization factor. And by default, it's 1, so there's a single function is going to process each shard. And this is going to set how many Lambda functions can process each shard. And you can actually configure this up to a number of 10. In this example, we're just using a parallelization factor of 2. And so this means you're going to double up your processing. Batching is still going to happen via the partition keys to maintain the order per partition key. That's going to be useful to know. So this is a really easy way to scale out processing on the Lambda consumer side without having to do anything on Kinesis. But back to, if we don't have parallelization factor, how does the scaling work? Well, remember, by default, there was that single function instance per shard. And Kinesis scales by adding shards using the update shard count API call. And so when there are more shards, Lambda is going to automatically scale up the number of consumers to match the number of shards. Still going to be message ordering in each shard, and so the maximum number of consumers is 1 consumer per shard. More Kinesis shards means more Lambda processing. So resharding in the Kinesis world also allows you to increase or decrease the number of shards in a stream to adapt to changes in your streaming data. So you can then decide where you want to split an existing stream, and then you're going to create 2 new child streams that split the partition keys of the parent shard. And the parent shard is still available, but then enters into this closed state. And the consuming Lambda function to maintain ordering is going to finish processing all the records within the closed shard, before then receiving records from the child shards. So once the records are processed in the parent shard, it becomes expired, and no more records will be processed by that shard. Now, previously we only had 1 Lambda function processing the shard before splitting. Once the child shards are now then open and available, then now there are 2 Lambda functions, which is going to be increasing your throughput. So the Lambda function is going to process the shard once per second for a set of records, and then synchronously invoke the Lambda function. If the processing is successful, it's going to move on to the next batch. And if not, again, the retry and error behavior depends on the event source mapping configuration. Now, when using the default settings over here, Lambda is going to invoke the function again with the same batch of records, and again continue to do this until it's successful, or again the records go out of the stream. But this may not be ideal for large batches. So with Kinesis, there's this really cool functionality called bisect batch on function error. So in a batch processing failure, which is often caused by a single poison pill record within that batch. And this feature basically helps to find that strange record. So what happens is Lambda is going to split the batch in 2 and retrying the oldest half of the records first. And this splitting process is then going to be repeated recursively until it finds the 1 record that is causing the failure, and then the rest of the batches are going to process successfully. So it allows you to hone down onto that message. And then the batch with 1 record is retried until it's successful, and this then is going to respect the maximum number of retries and record age in the stream. And in this case, earlier retries don't count towards the maximum retries. And then for records that are retried the maximum amount of times or have aged out of the stream, they are then discarded. And oftentimes you want to save these messages, so again you can use Lambda destinations and configure a failure destination and send those records to this destination, so you can keep that record. So when we're talking about, in the last section over here, we're talking about Kafka and Kinesis. It's all about managing performance, because that's why we've picked a streaming service, because we want to have a huge amount of data and we want to make sure things are processed successfully. So there's sort of 2 considerations that you need to think about when you are processing your data streams. One is the individual Lambda function. How long is the individual Lambda function? How does that work, and how does that processing work? And then also the end-to-end processing. So the amount of time from when a producer is going to produce a record until a downstream service is going to do that, what is the end-to-end time of all of that testing? And to do this successfully, you want to sort of have the concept of a baseline, because you want to understand what's going on. So you want the baseline on the stream, and you also want a baseline on the Lambda function. So on the stream, you want to understand what are the average records per second, and what are the average bytes per second. Then on the Lambda side, you want to know, well, how long does it actually take to process a single record, and then how long does it take to process an average batch size? And then if something goes wrong or something changes, you have at least a little bit more information. Has there been an increase in the volume between your partition and the shard, so something on the Kinesis or Kafka side, or has the size of the records sometimes got much bigger? Some producers decided to put a whole bunch more data. Then on the Lambda function side, well, are you having any errors? Is your Lambda function throttling at all? Because of course, anything that's going to affect the duration of your Lambda function, or the number of invokes of your Lambda function, or any kind of retries is going to impact your overall performance of your stream processing. So obviously metrics are going to be important. You want to know what's going on. And on the Kinesis side, it's natively integrated with CloudWatch. And these are metrics that you configure for your streams. They're just automatically connected and pushed to CloudWatch every single minute. And there are several useful metrics for monitoring streams and shards. You've got the get records iterator age milliseconds, which measures the difference between the age of the last record consumed and the latest record that is put onto the stream. And if this is too high, it basically means you aren't processing your data quick enough. And generally, a sort of rule of thumb we say is this value should generally not exceed 50% of your stream retention. Because obviously, if you're going to get 100% of your stream retention, you're going to lose your data. So if you are getting behind, maybe a temporary stopgap is to increase the retention time of your stream. And then obviously, the better solution is to add more consumers to keep up, but at least you're not going to lose any of your data records by being able to increase that retention time. You can also then monitor the read and write throughput so you don't get throttled. And you can monitor that producers are successfully putting records onto the stream, and also that consumers are successfully getting the records off the stream. And you can monitor this for any changes or spikes. And these are stream level metrics, all the basic ones, but they're also enhanced shard level metrics that you can use. On the Kafka side, MSK, because it's MSK serverless as part of AWS, is integrated with CloudWatch, and you can also push self-hosted Kafka metrics to CloudWatch there as well, so you've got a one place for all of your metrics. So, don't need to go through it all, but similar to Kinesis, there's default monitoring and enhanced monitoring, and you can monitor the consumer lag and the consumer offset to know how your consumers are doing. And of course, you can use also Prometheus for your streaming metrics. In the Kafka world, Prometheus is super useful and super important. So yeah, Prometheus is also natively supported. So there are also on the Lambda side, there are also several useful metrics for monitoring the Lambda function consumers. You can set alarms on errors and throttles when these go over 0, so you can do some investigation. And also monitor spikes in your duration. And this may indicate if the consumer is slowing down for some reason, so you can then go and take corrective action. Lambda is then going to emit the iterator age or the offset metric, depending on Kafka or Kinesis, when a function finishes processing the set of records. And this from the Lambda side then indicates how old the last record in the batch when that was finished processing. And you can use this then to estimate the latency between when a record is added and when a function is able to process it. So how do you manage throughput and scale, especially if your iterator age or your offset lag is growing? Well, the first thing is think about your filtering. Filtering is just going to drop the message, and this is going to avoid processing records. It's not even going to get you a Lambda function. That's going to speed things up. It's also going to reduce your costs because you're not doing any filtering within your Lambda function to drop anything. So yeah, you want to increase your processing throughput. If you are using filtering, or filtering is an option for you, that's really the easy way. The other way for Lambda is to increase the amount of memory allocated to your function. So Lambda can be configured between 128 meg and up to 10 gig, and this has a corresponding up to 6 virtual CPUs. So adding more memory to a function allows it to process faster. So for even if you're doing some CPU level processing within your Lambda function, adding more memory is going to add more virtual CPUs, and your Lambda function is going to process things more quickly. You can obviously optimize your function code so it needs less time to process records. Maybe you can do some optimization for your initialization process, or you can use some different libraries, or you can remove some libraries that aren't being used. But of course, to speed up your Lambda function, optimizing your code can be an easy win. Then you can also actually increase the batch size. So this has more records in a single invocation. So if you've got a really slow init time for your Lambda function, maybe this is going to help. So that's certainly another option that you can do to just do things quicker in a single batch. Now, errors is also something to carefully look after. Because it's streaming and we're all about sequence and about things being in order, errors cause sequential processing to actually stop, because it can't process anything during the retries, and if you've got many retries, it's just going to keep sort of spinning its wheels until you're able to carry on your processing. So really take care and think about how you're going to gracefully handle those records. And now with the functionality with event destinations, you've got a lot more functionality to get rid of that poison pill really quickly and try and get that processing happening much quicker. Obviously, on the Kinesis side, you've got the bisect on batch. So if you do have some weird record, you can just bisect that batch and carry on processing the successful batched records without having to process the whole entire batch. Obviously, you can use some logging and instrumenting your code can be really useful to help you diagnose errors. Lambda functions integrate with CloudWatch, but also a number of other third-party tools. So if you're using any number of partners, you'll be able to gather those observability metrics and use it with your favorite tools. And then often, think about your Lambda concurrency. This is the number of Lambda functions that can run in parallel at the same time. There are some limits to do with that. If it reaches a limit, there is going to be some throttling. So if you are getting throttling, your Lambda functions aren't running as quick as you think they are, and that's something you can do. Specifically, if your account concurrency is a little bit too low, literally it's within the service console, service quotas console, you can just go up your account level Lambda concurrency. It's one setting, and you can set it. It can go up to hundreds of thousands, but if they're smaller amounts, it'll just be done automatically, and you are solved. So then also on the increasing the processing throughput on the stream side, we spoke about the Lambda side. What can you do on the stream side? Well, the big one is evenly distributed those records between the different streams using an effective partition key strategy. This is really the number one tip: is try and think of what your partition key strategy is, because that's going to dictate your throughput. Remember when I was talking about earlier having a single consumer ID? If you've got one busy consumer which is doing stuff that's only going to go to a single partition or a single shard, and all the other shards are going, give me data, but you're not sending data to that. Remember, with Lambda and Kinesis and Kafka, it's going to scale up the amount of processing based on the number of partitions or shards. So increasing the partitions and the shards is automatically going to increase the number of Lambda consumers, and that's just going to follow through for your whole processing pipeline. Some people do say you can buffer some records at the producer side, and this allows for some fewer Lambda invocations, which can also reduce costs. Some people say that can be useful for them. And then, of course, on the Kinesis side, you've got the increase the parallelization factor up to a factor of 10, just 10x times of processing. That is on the Lambda side rather than the streaming side. And then the enhanced fan out is going to just give you more network throughput and have dedicated consumers onto your stream. So we've been through quite a bit, I think. We talked about in the beginning, talking about data streaming and use cases for that. We talked about the different streaming data on AWS and how you can use Kinesis and Kafka, and about then into the streaming architecture of what brokers are and what records are and offsets are, and the starting timestamps and all those kind of things. So hopefully for people who specifically in the Lambda world wanting to understand how the bits and bobs of the streaming work, that'll be useful for you. And then we went on a bit of a deeper dive into specifically processing streaming data and to Lambda with the Event Bridge pipes and the Kafka Connect, Confluent Connect, and then onto the Lambda event source mapping, and spend a good bit of time going through all the network nuance for Kafka, and then hopefully going into more enough detail for you to be able to effectively do your processing. And then finishing up on the all-important things with some information on managing your performance and managing your streaming. So that's it. There's plenty of other opportunities here at AWS and at home to continue your serverless learning. There's the AWS skill builders, there's some ramp-up guides, and there's some digital badges you can earn, which I'm sure you're dying to show your knowledge of serverless services on AWS. If you aren't aware, a great utility is Power Tools for AWS Lambda, available for Python, TypeScript, Java, and .NET. This is a utility. You can add a bunch of utilities you can add onto your Lambda function, and specifically for streaming data, it's got a batch processing features and idempotency features, and really easy. So instead of running a whole bunch of glue code that you need to integrate with streaming sources and a bunch of other kind of sources, I would seriously suggest you take a look at Power Tools for AWS Lambda. Also, there are lots of other things going on. You can visit us at the reInvent Expo, which is at the Venetian. There are plenty of experts to chat at the AWS Village. I'm not sure if you're aware, but you can actually get a free coffee at Serverless Espresso, and it's not one of the sort of other conference kind of coffees ones, which aren't necessarily are the best. So come and learn about event-driven architectures at Serverless Espresso. There's also the AWS Modern Application and Open Source Zone. Lots of information about serverless and event-driven architectures, and plenty of people to talk to. And another thing we're also doing at reInvent this year is something called serverless video. If you search up serverless video, we've built a live streaming platform to do videos with a lot of post-processing video analysis using some cool Gen AI tools. So certainly take a look at that. The last one is serverlessland.com. This is a website my team has put together. It's literally everything to do with serverless on AWS. I mentioned earlier the learning guides. There's a Kafka learning guide, a general AWS streaming learning guide, and I think there are 30 or 40 learning guides from APIs to governance to a whole bunch of things. Some of our experts have put a lot of time and effort into putting those together, so hopefully they're useful for you as well. That's my time today. I really appreciate you spending your first reInvent breakout session today For the people in the overview room, thanks so much for joining us as well. And if you're watching this recording afterwards, appreciate you sort of seeing you in the future, I suppose. But yeah, thanks so much for taking the time over there. I'll be around if you have any questions. All my contact details are on the slide. Enjoy the rest of your reInvent. Thank you very much.